I hope you're having, okay. Okay, good. I hope you guys are having a great Friday. So today my topic is going to be about forensics and using Ansible and VMware vCenter. So I called it data acquisition via or the Ansible way. So who am I? I am a 5th year BSMS student. I used to run Next Hub as a club, and then we transitioned as an interest group within RITSec. I am a blue teamer by heart. I used to be a red teamer at RITSec. I have done quite a bit of competition here at RIT. You can see them here listed, a lot of acronyms. I'm interested in automation, infrastructure as code, digital forensics, and home lapping stuff, and cloud security as well. My hobbies include soccer and hiking and listening to music. All right, so let me start by defining Ansible and what Ansible does. So Ansible is a configuration management tool that lets you run a specific task on like multiple hosts, be that using SSH. So if you have SSH running, you can pretty much do a lot of stuff using Ansible. And as you can see here, this is your laptop. You have something called inventory, which is the IP addresses of the host you want to deploy the tasks to, and then the playbook, which is a collection of tasks. And you run them using SSH. If you don't have SSH running, let's say Windows, you can use something called WinRM, and you can deploy to Windows as well. So that's Ansible. And then what is vSphere or E6i and vCenter? It's E6i is hypervisor type 1, which is essentially a server that you can run specifically, or it's a hypervisor type 1 you can run on like bare metal servers. And then if you have multiple E6is, you can single or you can manage them in a single host called vCenter. And this is what we're going to be using today. And yeah, so backstory to my project. Back in the summer, I did a little research in AWS, and I came into a situation where I have to do a little bit of forensics analysis on a AWS EC2 instance. And then I was looking up a GitHub project that does this by default. And then I found this great project developed by Google called Cloud Forensics Utils, which by like so far it only collects disk images only, and it's still under heavy development. I think the last release was last week, if I'm not mistaken. And it only supports Google Cloud and Microsoft Cloud and AWS, which is sad. Because I was getting in the opportunity of like VMware is not supported, so I had to use my own module. So my project essentially is a Ansible playbook that runs that connects to vCenter via the API, and then it contact or connect to a VMs, if you can see here. And it collects the images from VMDKs and VMEMs. VMDKs is essentially the disk images, and VMEMs are VMEMs and VMSN are essentially what's used to collect, let's say, both to run or to analyze the memory images as well. So with that said, I'm gonna go to the demo. And for the record, I don't have, or demo god is not fond of me. So if anything happened, I'm gonna, don't blame me, blame him. Can you guys see the screen? or should I enhance more? Hello, can you guys hear me?
Yep, just a little bigger, Ali.
Okay.
Perfect. Awesome.
Well, so I'm gonna first start by cloning the project. And let me get into a virtual environment. So actually, I'm gonna go to code here and gonna explain what's happening here. So we have something called dependencies, which you have to run before you run the project to install Ansible by Vim. One second. So we have a Python module, this is written in Python to contact the vCenter API. And then we have this module, which essentially is a JSON module to parse JSON files. And then the community VMware tool. So I'm gonna install the dependencies. Gonna run them in bash. Now let me go back. So let me run through the project real quick. Come on. I'm gonna do it in here then. So after this installs, I'm gonna show you the layout of the project if this decide to show up. So, okay, cool. So this is the whole project. You have something called site.yaml, which have the two roles, one for the memory acquisition and one for the disk acquisition. So we also have the vars file, which includes your username, host name, vCenter, username, password, the data center, and all the data store that's within your VMs. And then you have the cert validation. I don't have one, so I set it to false. I also have the directory name I want the data to be saved in, and all the compromised VM, which you can do them in a list as well. So I've already written an example of this, and I'm gonna copy it into vars. So, and don't worry about this. This is just a demo user. It's not OPSEC, so I'm gonna delete it afterwards. This is taking longer than I expected. So I'm gonna save the var file, and then once this decided to load, I'm gonna run it. So while we're waiting, I can show you on the slides. I run the tool in 2 VMs while acquiring the memory analysis, and both of them were 4 GB. And it took about 3 minutes. And for the disks, which is a lot longer, for 16 GB for 2 VMs, it took about 12 minutes. Don't worry, I'm not gonna run it. I already have the images I want, but come on. You know what? I'm gonna do this instead. This should be relatively fast. Here we go. So you guys can ask question in the on Twitch if you want. I can answer them while this decide to run eventually. Okay. That's why I have just in case file. I'm gonna run the one that actually ran. I've already run the dependency file in here, and I have the vars file as well. So I'm gonna cd into the project one more time, and I'm gonna run Ansible. So you can basically just run Ansible with the playbook and the site file. This is gonna take a very 1 second. I'm gonna run this in a tmux session. This is going to take a very long time, about 22 minutes. So I'm not going to show it. But this is the two VMs collecting the data from. And if we hop into vCenter real quick, I can show you what's happening. So these two are the two images I'm collecting the data from, and this is the instance I'm running Ansible from. So it's collecting the data from this one and this one. Typically, these two will be running, and then you would take a snapshot, which will collect the memory image. If we decide to take a snapshot, we can do this, but we have to run it first. When we take the snapshot, we need to include the virtual machine memory, which is what I did in Ansible. And then afterwards, when it collects the disk images, it needs to shut down the VM. So it's very important that you run the mem acquisition first if you need the memory. And if we go to a new session or a new page, and then cd into just in case, which I have already run the file in, we will have a new directory called Forenware data. And if we cd into it, we're gonna have two folders. The first one is disks, and the second one is memory. So let's take a look at, oh, I don't have to. Let's take a look at disks. So I have 3 images. This one is irrelevant. So I have two of them. If we cd, let's say, for example, into Ubuntu, and we want to look at the VMDK file. Let's see the. It's a disk image, and if we look at how big it is, it's 3 gig. So I'm more comfortable with the raw data. So I'm going to convert this using an OpenStack tool called Q-img, which essentially converts the VMDK to a raw image. And you give it the file VMDK and the name of the file of the raw file. This takes about 2 minutes. So I've already run it. You don't have to wait. So let's say we want to see the how long is or how big is this image. We can use something called fdisk, if I'm not mistaken, fdisk -L. And then we can see that we have 2 devices. The first one is essentially the ISO file, the one that it's putting from, and the other one is the actual VM. So we can do stuff like if you want to determine the operating the extension. I don't remember the name of it, but essentially the type of the raw data. You can use a tool called fsstat, and we have to give it the offset of the starting of the VM. And let's see what's going to give us. It's going to give us the ext4. And let's say we want to see the file system body. We can run a tool from the slot kit called FLS, and you give it the type of the extension, the offset. I'm not sure what the dash M is for the Mac time. The dash D, I'm not sure. And then you're gonna point it out to FLS body. It's gonna be a little bit gross, but there is a tool called Mac time, which essentially maps the FLS body to the timeline. So if we cat the Mac time in here, we're gonna see fancy stuff. And this is actually showing the what do we call the deleted file from the image I ran. I think I ran rm-rf in here once, so you can see all the images are getting all the folders in the slash got deleted. So that's for the disk images. Let's look at the memory. Look here, we have something called vmem and vmsn. This took me a while to figure out. I thought we only needed vmem to run volatility, but apparently volatility needs vmsn as well, which is essentially metadata for the actual memory file. Let's take a look. So the SIFT, the volatility in SIFT doesn't work. So I'm gonna cd into, or I have already git cloned the volatility in temp. We look at, yeah, we have volatility here. So I'm gonna run, let's say we wanna run some memory forensics analysis on vmem here. We wanna run volatility. So we need first to, like typically in an analysis, you want to know the type or the profile that this image belongs to. So you would run a command called image, what is it called? Image info or KDBG scan, which essentially figures out the profile that you want to, that's the image belongs to. So this also takes about 2 minutes. I'm not gonna run it. I already know the profile name. So I'm gonna run so the command goes like this: Python, and then the path to the volatility binary, and then which file you want to run. In this case, we want to run the Python Windows 10. And then we want to run a plugin called Hive List, which essentially lists all the hives in the image. And this is a very fresh image, so you won't see much in here. Typically, you would see a lot of hives in here for each user, or for the user you dumped the memory from. I think I dumped this from an administrator user. Let's also run another one just to make sure that the memory file is not corrupted. So we will do hive scan, which essentially shows the offsets of each hives that we saw above. And I'm not sure what else we can run here. Oh, we can run the process list in here as well with PS list plugin. And as you can see, there's a lot of processes here. So let's go back to what we originally ran and see if it's still exporting the VMDK file, which I told you before, it takes a very long time. So yeah, let's go here and I'll show you how does it look like in the store images. So if you look in the files, I have Ubuntu demo and Windows 10 demo as well. So what I'm exporting here is only 2 files or 3 files. First one is the VMDK, which this one, which is about 16 gig. And it gets compressed to 3 gig, as you can see. And let's go back here as well. And the other file is vmem, which is the memory, 4 gig, and then vmsn. Because I run this 3 times, it's not gonna run the vmem, it's gonna add it to the vmsn, which is the metadata file. So this one is the biggest one, because it was, I did this after it with a couple of seconds, just to test it. It's essentially the same. So you only need 3 files, vmem, vmsn for the memory analysis, and vmdk for the disk analysis. Same thing for Windows as well. I guess, yeah, and this is for the stat I told you, how long does it take? And these are references that I used during the project. This is a very, very good YouTube channel. I essentially used it every time I want to learn about DFIR. And also Ansible docs is very, very helpful. And if you guys have any question, let me know. I'll be happy to answer. That's basically it. So Dan asks, are you running Ansible against vCenter or the forensics host? Yeah, I'm running. I can show you the roles file actually. I'm running that against the vCenter API. So I use modules like community VMware VM info to extract the virtual machine info. I run commands like power state to get the power state information, commands like exporting OVA to get the MDK files. Same thing here. I'm essentially running that against the vCenter, which is why we only use in the var file, we only use the username of vCenter and the password as well. And you can add, I didn't mention this before, I think, you can add up to as many as you want of data stores, because it's going to loop through all of them to determine where these 2 virtual machine belongs to. And also you can add as many virtual machine to speed up the process of extracting the data as well. Thank you. With that, I guess I'll turn it on to you guys.